All right, so we have already learned how to calculate pH, so just a couple reminders. You do have these two equations. So it depends on which one you're looking for. And in our warm-up yesterday, we saw that if we're given information about a base, okay, if you're given information about a base, you use your POH. If you're given information about an acid, you have to use pH, all right? And so we've run through a few of these examples. It's pretty easy. You just type it in your calculator. Remember that you use that whenever you're given information in like molarity, okay? So whenever you're given information in molarity. All right, so the next thing we've got is the opposite of this, all right? And so what we're going to do is we're going to do the opposite of log, which is base 10. That's what log is for, all right? So for base 10, what you are typing in now is going to be 10 to the negative pH. So go ahead and write that down. Okay? And then if you're given POH, what do you think we're going to do? The same exact thing. I agree. Just a second. Sorry, I wrote that very ugly. I'm going to zoom in so I have room. Yes. There we go. All right. Whatever. Thanks, second period. No, I'm just kidding. All right, so we've got 10 to the negative pH, okay? And then the other one is going to be 10 to the negative POH, all right? The important thing that a lot of people forget is that negative, so don't forget that, all right? So what this allows you to do is I give you pH. And so one of the labs that I'd like you guys to do is I'm going to give you a little pH sensor. I'm going to give you some unknown liquid because we have about 15 that we found back there. And you're going to test the pH. I know what at least substances they are, but you're going to get the pH. You're going to do this little calculation. You're going to tell me what the molarity is, so now we can label our bottles. All right? Sound good? So you guys will do that next week. All right. So this one allows you to get concentration, and that's the important thing about this, all right? So it allows you to get the things that go in brackets, so you can either get your H+. Which one will give you H+? The one with the pH, right, okay? Which one will give you the OH concentration? The POH, right? Okay? So when you're looking for that, when you're looking for the molarity or the concentration, you're going to use this, okay? Given pH. Are all clear on that? Yes. So it is opposite. What?
So what happens in the lab, we're going to test it with like the pH paper, and then if it's a base, we find the pOH instead of
You're going to use an actual sensor, so you'll get a very specific number.
But I'm saying, like, how do we know which equation to use? We use...
All right. Okay. So the next one, so just remember that you do still have that pH plus POH is 14. So if you find one or the other, you can always do the subtraction to figure out the other guy. So the other part of the scale, all right? The last equation I'm going to go over today is going to be this, all right? And what we're dealing with here, you guys learned Ka and Kb yesterday. This right here, this 1 times 10 to the negative 14, this is Kw. So what was the K for? What did we call those Ks? Remember what they were called? Called ionization constants, right? Okay, so this is your ionization of water constant, basically. All right, so this number never changes. That's a number that's given to you. It's on your periodic table. You can find it, I think, on the inside. Okay, so if you need that constant, you have it there. What you're going to do is, if I'm given concentration, if I've either given the concentration of my acid or my base, I can find the other by just using that. So I don't have to run it through the pH calculation and then switch it over and then get the concentration. All right, so this is just a one-stepper here. So what you're going to do with this is given, let's go down here to this little table. Okay, so when you're given something like this, what is this information? This is your concentration of what? OH, right? This is your base concentration. So if I wanted to now find my, there you go. If I wanted to find my hydrogen concentration, or your acid concentration, we would just plug in Kw over that. So we would say 1 times 10 to the negative 14 divided by this 3.5 times 10 to the negative 12. Okay? But remember, instead of writing that times 10, when you go to your calculator, make sure you use the E. Okay? Make sure you use that. So it would be 1E negative 14 and 1E, or 3.5E negative 12. So go ahead and type that in and let's see what we get for our H3O concentration. Does it say to play log? Okay, then don't play log.
Who needs a calculator? I'm tired of it. 1, 2, 3.
All right, so what are we coming up with for our answer? What is it? Put it into scientific.
Yes. 2.9 negative 3.
Good. Sounds good. All right, so 2.9 times 10 to the negative 3. Okay? So if you got 0.00029 or whatever, if you got this. If you got that, that's right. You're good. Okay? All right. They're the same number. Okay. All right. So that's how you use that calculation. And what we could do also is if you're given the H3O, we could then use it to just find your OH. So KW always goes on top. KW is this one. Okay? He always goes on top, and then you put the other concentration below it, and you can find the concentration that you need. Now, let me just really quick go over where that comes from. So the whole idea, I've kind of told you in the past that when you look at your exponents of your concentrations, let me kind of zoom out here. Okay, when you look at your exponents for your concentrations, such as, say, this one over here, that -2, your pH ends up being about the same. Okay? So since we know that, why are we doing this? How do you multiply exponents? How do you multiply exponents? You add them. Yeah, exactly. You add them. So what we're talking about for water has a pH of what? 7, right? It's balanced, which means you have equal parts of acid and base. So what we're kind of doing here is we're saying 10 to the negative 7 times 10 to the negative 7. And that gives us that 10 to the negative 14. And that's where your auto-ionization of water constant thing comes from. Okay, so just so you know, that's where that random number is coming from. It's your pH scale. It's saying equal parts, or you'll have unequal parts, which is what you guys found. Okay? All right, so I would say let's do number 1 and 2. And then down here, I want you to try and do this first row. Okay? And then we'll go over the answers. Cool? Cool. All right, so when we go to approach number 1 and 2, forgot to push the pen button. All right, so we go with number 1. All that you were doing was 10 to the negative 11. Okay, when you have a straight pH, like with no decimals after it, that's always going to be that 1 times 10 to the negative 11 concentration, all right? And this is concentration of, it told you you're looking for H3Os. So since we're using all pHs, that means that's all it can be, all right? So you have your molarity of acid, okay? All right. The second one is not as straightforward. You did have to plug this one in, so I'm going to ask you guys what you got. But you did 10 to the negative 4.1. So you should have gotten 1 time, nope. What did you guys get? Sorry.
7.94.
Thank you. 7, as I just said it too, right? 7 point what? 9 times 10 to the negative 5th. Okay, so I do want you to notice though, this negative 5, you guys take a look at this. This negative 5 is still very close to what your pH was. All right. So when you're just trying to guesstimate and you're trying to go through a multiple choice really, really fast, like my AP kids have to do, you can kind of look at that and find your best answer choice just based off of exponents. You don't have to plug it in or anything. All right. Huh? Kind of ish, yeah. Kind of ish. All right. So the next one that I gave you was was that little table, so I'll move that up top. Okay? And what we've got is we're given a pH of 7. Somebody tell me what did you do from there? We start with a pH of 7. Did anybody pick a direction to go on that?
1 times 10.
That's true, but okay. So we're gonna go to concentration first, is what I've heard. So we're gonna say H3O. We can solve by doing what? What did you have to do though? What did we just do just a second ago? Right, there we go, there it is. We did 10 to the negative 7 to get pH, right? But we do know that since it's a straight pH, it equals 1 times 10 to the negative 7 molarity. Okay? We see that? Then, after that, what can we do? We have 2 options. Because you can either solve for OH first. Let's do that one. We'll practice our KW. Okay? So OH, what do we do? You do a dividing, but who's on top? 1. 14. Good. We have our KW value. Okay, it's always 14. Good. And then we're going to divide it by our 1 times 10 to the negative 7. Okay, so when you get that, if you can do exponents in your head, remember you subtract when you have them in division. So you would have 1 times 10 to the negative 7. Okay? Now how can we get POH? Nope. Well, yes, you could do that. So POH, you can do either 14 minus your pH, right, which would give you 7. What's the other way, though? Just so you're ready for it. How do you get POH? Look above. Look at the top of your page. Yes, there we go. We could do negative log of this 1 times 10 to the negative 7. And you would also get your answer. So what is it? 7. Good. All right. So you got to be able to fill out one of those tables. And that's kind of it. Okay? Okay, in case you need help with the calculator, what you're going to do when you go to calculate your pH is you are going to be pushing, let me get red on here. Okay. So I'll get yellow. So what you're going to be doing is you're going to, we know that we need to type in 10 to the negative 4.1. And I know that some of us don't know what this part is. So you're going to hit your 10. You're going to hit this little caret button. And you're going to say negative. And you're going to say 4.1. Okay? But this is one option, is that you can do that. Okay? And then when you do that, your screen is going to look like this. Okay? Your other option that you can do, it's just as easy, is you're going to push the second and 10. You're going to push second and log, and there's a little 10 to the x, and you can do that, and it comes up with this value, and all you have to type in is the pH. So that's how you're going to be typing that in, and then just don't forget your negative log for when you're trying to find your pH. And I would say that's about it.